Let's take a look at part A. So, first things first, I'm going to write down tan as sine over cos. So it's going to become 4 sine squared theta is equal to sine squared theta over cos squared theta. Now, there's a few approaches you can take from here. The way I'm going to do it is I'm going to multiply through by cos squared, 4 cos squared theta sine squared theta equals sine squared theta. And now I'm actually going to subtract sine squared theta from both sides. So I'm going to get 0. And then I can factorize out that sine squared theta. Sine squared theta 4 cos squared theta minus 1 equals 0. What this means is it's now factorized, so either sine theta is 0, I mean sine squared theta is 0, but if sine theta is 0 then sine squared theta will be as well, or cos squared theta is equal to a quarter, because I can set this bit equal to 0 here. Now you might have said, you know what, I could have got that earlier, I could just divide it through by sine squared theta, and you can do that, but you just got to make sure you include the solution sine theta equals 0. So that's why I've taken a bit more steps. I just think it's safer to factorize. Okay, so for sine theta is equal to 0, I'm gonna do it without a calculator. I can just sketch the graph. By the way, we're interested in 0 to 180. So I'm going to get that theta is equal inverse sine of 0 is 0. So I'm going to get 0, and I'm going to get 180 as well. So that's from this bit. And then cos squared theta is a quarter. So cos theta is going to be plus or minus the square root of a quarter, which is actually plus or minus a half. I'm just going to sketch out what cos theta looks like. It's going to look like this between 180. I didn't even want this bit here. So I can see I'm going to get one solution for a half and one solution for minus a half. And I think, what is it that gives us a half? I think it's 60 degrees, but we can do inverse cos of a half to be, just check. I can do it for minus a half as well. Okay, I'm not going to try and guess what that one is for the moment. So we get 120. And those are all the answers. So overall, theta equals 0, 60, 120, or 180. All right, taking a fair bit of time on that. I'm just going to talk about another approach that I've seen used that you could use. Just trying to remember what it is actually. You could change cos squared theta to 1 minus sine squared theta, so it becomes 4 sine squared theta equals sine squared theta over 1 minus sine squared theta. This will work out. This will give you a quartic in sine squared. You end up factorizing for sine squared. I'm not going to do it right here. It will give you the same answers. So that's another method. You could also change sine squared theta to 1 minus cos squared theta and do something similar there as well. I would argue the way I've shown is the quickest. I don't get a quartic. I can just factorize out and get the answers. But I just wanted to talk about those other methods. All right, part B. This is a proof question. Okay, good practice for proof questions is to start from one side and get to the other side. Start from the complicated side and get to the more simple side. So the left-hand side, first things first, well, we've used tan as sine over cos, but there's another one we need to be aware of for AS maths. Sine squared A plus cos squared A is always identical to 1 for any value of A, which is why we use 3. It's all parallel lines here. So what does that mean? I can replace sine squared A by 1 minus cos squared A. So the left-hand side is going to equal 1 minus cos squared theta, just replace that sine squared theta, minus 1 plus cos theta, all over 1 minus cos theta. The 1 and the minus 1 are going to cancel, so then I'm left with cos theta minus cos squared theta, put the positive 1 first, all over 1 minus cos theta. Now we've got to show detailed reasoning here, so we're nearly there actually, but we just need to make it clear how this can cancel down. You can't just go crossing off cos thetas here, there and everywhere. The safest thing to do is to factorize the top, and then it just falls out because we can see we've got the same here, so we're going to get cos theta. And that's it. Now technically, I should just say it's equal to the right hand side. And then I'd even add as required. Now if I'm being really careful, I should use an identity throughout. But you know, it's quite easy to forget to do that. And then it is only true for cos theta is less than or equal to 1. You don't actually have to write it here, but when you cross them out, you should just technically say cos theta not equal to 1. That's a minor thing. Okay, hope you're happy with that.